Hello friends, today we are going to start with the very first chapter of this class, which is units and dimension, and basically we are talking about estimations. So what is this? See, in physics throughout the time we are going to study about various types of physical quantities. Now what are physical quantities? Let me name some. Force, mass, length, time, momentum, angular velocity, velocity, torque. They are all different sets of physical quantities. Now when I have to write a physical quantity, when I have to write or measure a physical quantity, how do I do so? See, physical quantities in physics are sometimes in this type, 3 into 10 raised to power 8. Sometimes they are 0.00000001, let's say. So the physical quantities do have various order of magnitude. Now what do we mean by this term, order of magnitude? So you will get it by example. A physical quantity is not just represented by order of magnitude. Actually physical quantity is a numerical value, then it is multiplied by the order of magnitude, which clearly gives us an idea about how big or how small the physical quantity is. So for example, if I take these two things, 3 into 10 raised to power 8, and I am taking 2 into 10 raised to power minus 12. So numerical value of this term is 3 and this term is 2, whereas order of magnitude of this term is 10 raised to power 8 and here it is 10 raised to power minus 12. So what is the numerical value? Numerical value is that one unit, basically it is greater than 0 and less than 10, which will be placed before 10 raised to power something. Okay, so that gives the numerical value, whereas order of magnitude is everything raised to power 10. For example, I just wrote a value 0.000001. Okay, this is basically 1 upon how many zeros? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. How did I write it so? 0.1 is what? 1 upon 10. So the number of digits after decimal point is equal to number of 0 in the denominator. So after decimal I have only one digit, so that means I have only 1 0 in the denominator. So number of digits here after decimal points is 1, 2, 3, 4, 5, 6, 7. So I'll be having 7 zeros after 1. 1, 2, 3, 4, 5, 6, 7. So now this thing is written as 1 over 10 raised to power 7. Why so? Let's say I have 0.01. I can write it as 1 upon 100. What is 100 basically? 1 upon 10 into 10. So how many times I am multiplying 10 here? I am multiplying 2 times. So that makes it 1 over 10 raised to power 2. If it would have been 0.001, I would have written 1 over 1000. That means 10 is multiplied 3 times. So I will be writing 10 raised to power 3. So that means the number of zeros in the denominator is equal to the power over 10. So here there are 7 zeros, so 10 raised to power 7. And this term, when it will go in the numerator side, it will become 10 raised to power minus 7. So whatever physical quantity this particular term was representing, the order of magnitude of this is 10 raised to power minus 7. So now you are very much clear about what is order of magnitude and what is the numerical value. So any physical quantity is represented by these two terms, which is numerical value and order of magnitude. Now, do we have any particular frame or set by which we define the order of magnitude? Yes, we have already named them. They are known as prefix and suffix. For example, I am writing names of few: kilo, mega, giga. So this is 10 raised to power 3, 10 raised to power 6 and 10 raised to power 9. Whereas if I write milli, micro, nano. So milli is 10 raised to power minus 3, micro is 10 raised to power minus 6, whereas nano is 10 raised to power minus 9. So these are prefixes which we use if I have to state order of magnitude of something. For example, 2 kilograms. Gram is a unit of mass. I have used word prefix kilo. So kilogram means 10 raised to power 3 grams. Mega miles, 10 raised to power 6 miles. Millimeter, 10 raised to power minus 3 meters. Micrometer, 10 raised to power minus 6 meters. Nanonewtons, 10 raised to power minus 9 newtons. So this is how we establish the relationship between a physical quantity, its numerical value, and the order of magnitude.